Welcome to the AI Guild podcast. In this episode, I chat with Maya Ackerman and David Loker, the creators of ALYSIA. ALYSIA stands for Automated Lyrical Songwriting Application. Let's take a moment to listen to an example of one of their generated songs.
Now that you're gone, I just realized I'm all alone.
This is just the beginning of a very exciting path for creative artificial intelligence. Maya and David are musicians themselves, which adds an incredibly relevant layer of context for all the work they're doing. They're also getting important feedback from composers about what type of needs they have when creating music with ALYSIA. The applications for this tool are immense. During the Industrial Revolution, the people that embraced the machines and learned to work side by side with them were the ones who prospered and dramatically increased their efficiencies. This was a big step for humanity. I believe tools like ALYSIA are laying the foundation for the same type of artificially intelligent revolution. Let's hop into the interview. All right, today we're here with Maya and David, and I wanted to learn more about what inspired your research. What was going on when the moment you started working on this?
That's a good question. So we were both doing research in machine learning around that time for quite a few years. And we both have some musical training as well. So for a long time, this computer science and arts world lived in parallel. And it was around the time that I attended ITA's workshop related to various things in and around information science that I found out about a community called the Computational Creativity Community. And I attended their main conference later that year, and I just completely fell in love with it. It's all about thinking about the computer as being a creative collaborator. And I believe it was that same day when that perspective became clear to me that I thought of, well, why don't we make something that helps us write songs? It's something I've been trying to find time for, but never could quite devote time to yet another hobby. Yeah. And it grew from there.
Cool. And so you mentioned the being in machine learning already. So, I mean, were you developing machine learning work, or were you in a PhD program? Like, what was the actual environment in which you kind of entered this moment?
Oh, that's a good question. I was already a professor. I was a professor at Florida State University. And David?
Yeah, so I've been in machine learning from when I was at the University of Waterloo, sort of studying theory of clustering, which is not very applicable. But then when I got out and I started looking for jobs, I got consulting work, and a lot of that was centered around machine learning. And so that kind of just took me down that path of sort of machine learning and being able to use that in data science and whatnot. And so then when we started to think about it as, making music, I immediately saw sort of where machine learning could come in and sort of make use of that to do what we want to do, which is make a collaborator that can create songs.
Yeah, that's awesome. It's a really great idea, and I would love. I mean, obviously, I've read your paper. I'd love to kind of hear in your own words, what have you built, and what is this thing? What is ALYSIA?
So how about I describe it, how to use it, and you can describe the back end.
Yeah, sure.
So from a user's point of view, we assume that the user has some kind of lyrics. So for example, recently we've been playing with Emily Dickinson's poem as the lyrics. So you feed the lyrics to the system about 1 or 2 lines at a time, fairly short segments. And for each sentence like that, you can get as many options for melodies for those lyrics as you want. So we sometimes ask for 5, sometimes we can ask for 70. Then the system ranks the melodies that it generates and gives you those melodies in that sorted order. And then you pick which ones you like, which from our experience tend to be towards the top.
Yeah.
Right.
And so David will tell you a little bit more about the background.
So, I mean, the idea behind it is quite simple, right? I mean, you think about sort of language generation and sort of how that's done, and then you take it into music, and really it's a time series, right? So you have a bunch of notes that have happened, and then you have a bunch of notes that are going to happen after that, and you're going to generate them one at a time. And other than that initial starting point, it all sort of follows that same framework as sort of language generation. And here you have lyrics that people have done, and music kind of, if you take a look at what music does, they tend to have some structure around the actual lyrics themselves. So you put together sort of a system that builds upon existing music that we build and sort of input into a training system in order to understand what melodies and rhythms go with what lyrics in order to help, generate a melody that's going to fit the lyrics that you're interested in.
Yeah, that's one thing I feel like some of the, I don't know if it it's been a bunch of generative type stuff, ranging from poems or some other type of text-based output. And I've seen a lot of long short-term memory neural nets. What it was, I know that in the paper you had a different approach. And do you have any comment on kind of how you thought about that, or had you had success with your own path before? Like, any comment on that?
So the reason why we didn't end up using something like long short-term memory or a deep learning approach is just because we don't have the data set size required for something like that. So if we were going to go down that path, we would need to spend a lot more time sort of building the data set. And at this point, we are doing it all by hand because we don't have it. It's in a specific format, right? So these sort of XML or MIDI files that come in order to know this is the lyric with this note and so on. And so we wanted to be able to build something in a reasonable time frame to sort of see whether the approach was viable. And so we built a set of music that's maybe, I don't know, 15,000 or so examples or training examples, and we wanted to be able to build something like that. And for classification, trees tend to be pretty decent as far as that goes without overfitting, and that's what we were going for.
Cool. Yeah. Yeah. Cool. Yeah, sorry. Go ahead.
What's interesting about machine learning is that much of the system remains the same, whether you give it a random forest or a sophisticated neural network.
Yes.
So, I mean, a lot of the work comes in with understanding what features you should be pointing out to your algorithm.
Right, and that was where I think we spent the most time, was actually trying to design the features themselves, and that required a lot of looking at, what is music, and how do we distinguish good music from bad music, and what are we looking for as a musician potentially? We have musician friends, when they compose music, what do they look for when they're creating?
Yeah.
And there are certain things about the movement of the music and sort of how far it's gone, and different structures of music that you need to build in. And there are lyrical features because we're building something around lyrics, and all these things play a part. And I think that was by far the most sort of time-consuming part of it, was deciding, okay, how are we going to model this in a way that's going to get us accuracy? And as I think since you read the paper, you saw for pop music, actually we got pretty good accuracy in a model that was able to do pretty given set of lyrics.
And why do you think? Do you have any hypotheses on why pop music had more success than other genres? Was there a particular genre that performed very poorly?
Oh, so the first thing we did was with pop, and that worked quite well. It was very successful. And then we took Puccini operas. So actually, both of us have opera training, so it was kind of fun to look at some opera. And we were very optimistic, and we set it in. And the success rate, given the same features and the same model and everything, was significantly lower.
Yes.
It was still very much far ahead of random, so we still were able to learn something. But it wasn't nearly where we wanted it to be.
Yes.
Part of the challenge was also that we switched languages from English to Italian. And there's a little bit more support for the English language online. For various APIs. So that's one of the things we're working on right now, is to have our Puccini system, which we call RoboCini, to have bring that up to the same level as our English system.
Right. Yeah. And that one is kind of interesting in that we reached sort of a point where we actually tried more complex models and tried various other things to try and bring the accuracy up, just to see, where is sort of the point, the threshold of what we can get to. And it seemed like actually, forests were basically right around the sweet spot. You increase it anymore, and you just keep overfitting to node. Which basically tells you, if you're a machine learning person, you're looking at it, your features are not right. You're not capturing whatever the structure is in opera is more complex, and somehow the dynamics are more complex than what's at play in pop music. And I'm sure most people who know the two, would agree with that statement. But it bears out in the machine learning prediction that opera is more complicated than pop music.
Absolutely, yeah.
Yeah, it's really not as easy to predict than pop music. So go figure.
Yeah, and I think of even some of the hip hop differences. I happen to have listened to a decent amount of hip hop, and the differences in artists, especially as time has progressed, and I know the complexity in some of them is really actually really interesting and an achievement. And then there's some of them, maybe 2 Chainz would be a great example of like the most random lyrics that don't have anything to do with anything. And I think of that, I'm like, oh yeah, that makes a lot of sense, of like, that's effectively pop in that genre, which yes, the complexity is low.
That I've had that I wonder if you go back and you take decade upon decade and segment them out, if it gradually gets worse and worse at predicting as we go back, or music has somehow gotten simpler and simpler over time. I don't know, but it's an interesting sort of anecdote that opera is so much more difficult.
Well, there was a time, I think it was Mozart's time, that they used to have these algorithmic games for generating music. So it was very, very algorithmic. It was just, you could essentially mimic it with an expert system. But it hit a peak of complexity at a certain point.
Yeah.
Yeah, I'm not very well educated in musical theory, but I feel like I've heard stories about there were certain rules in how you wrote music, and that there were certain artists that broke those rules, which then kind of made their music so unique and amazing.
Yeah.
Cool. So what was the most challenging part working on this?
Well, there were, I mean, I think getting data at first was really, really difficult. Then when we managed to get over that hurdle, I think, like with many machine learning systems, finding the right features, which essentially tell the algorithm what it should be considering it. Because it's not an expert system, it doesn't tell it how it should be using it, but without telling the algorithm which features to look at, what are the things that might be important in making melodies or lyrics, then it has no hope.
Right. So I think this is one of the distinctions of the algorithm versus some others that have existed in the past, is that there's no human intervention. There's no, I know that music should be this way, and I'm going to, any music that it generates that, defies that, I'm just going to throw away. We don't have that, right? So we have to make sure that our data set, like all machine learning, is clean. So we're getting, garbage in, garbage out. We're trying to give it exactly what we're trying to predict, and we're trying to make sure that the features can encapsulate what music is. And those are the two longest projects, I think. And aside from that, the last little bit has been getting an evaluation scheme that seems to work, right? So it's getting, and it just relies on the model. In the end, it's purely based on the probabilities that come from the underlying model. But the idea behind it is, how do we rank these things, or how do we have the ability for the user to throw away bad ones if they want to, or like set a certain bar, like maybe you'll get less random and less new kind of exploratory music, but maybe it'll be closer to what they're looking for. It just kind of depends, and let the user play with it. And that's been the last sort of hurdle in the product, which was just getting that evaluation scheme.
That's a really important concept in computational creativity, is that the machine shouldn't just be generating stuff. Because it's believed that a lot of what it's going to generate can potentially be useless, and so it should also be selecting among its own pieces of art, if you will.
Yeah, makes sense. Yeah, that's the data labeling. I mean, you mentioned the feature extraction, and I think in the paper you had listed a bunch of different features. Are there actually more features than that, or was there some that you thought might be really interesting that ended up not being part of the model?
Quite a few, yeah. We're still working on the system. We want to make it better, more flexible, more easily able to go between languages and genres. And there are quite a few other features that we want to integrate.
Yeah, so there's still an open question as far as what features are the best. And right now, the highest weighted features come from where it is in the beat. So where it is it on beat, off beat, there's certain musical concepts of the strength of the current beat that you're on, and that plays into what vowel you're on and things like this. And so those features tend to be prominent along with what previous notes are. Obviously, what the previous notes are by far the most indicative factor of what the next note is going to be. But I have other ideas in terms of potentially, instead of doing it note by note, but having it be the change in notes. So rather than looking at the notes themselves, look at the intervals of the notes, and now that frees up some flexibility and potentially shrinks the space a little bit, so you don't have to have quite as many training examples, because you're talking about intervals as opposed to, I'm going from note 1 or scale degree 1 to scale degree 7. It's just a +6. So that occurs if you go from 2 to the next octave or 3 to the next octave. It doesn't matter. And so at that point, that's an open question, and there's a whole bunch of stuff that's still open for research, essentially.
Oh yeah, it's a lot of stuff related to language as well. We want to have more features extracted from what is the word for which we're currently constructing the melody. Possibly even some analysis on the complete sentence. that perhaps lyrics for sad songs tends to work a little differently than for a happy melody.
We don't have a feature, for example, if you're a lyric, there's obviously sentiment analysis in machine learning. We don't have anything that's currently like, what is the sentiment of the sentence?
Right.
Things like this. And obviously then if you change languages, that becomes more difficult again. And things like this, because there's not a lot of corpuses out there to help you tell sentiment from from Italian or French or Spanish.
Actually, I just thought about something recently that in Italian, it's actually particularly difficult to do what they're trying to do, because depending, if you have vowels with adjacent syllables, you very often morph them into a single note. There's special singing rules in Italian that don't exist in English at all.
Yeah. Go ahead, sorry.
Yeah, I mean, there are features that I think that are in there that are much less important, and then there are ones that are more important. At this point, we're not overfitting at all, so we're not worried about throwing them away at this point. But once we get to a certain level, potentially we will have to start pruning. But yeah, right now the model is simple enough for for what we're trying to do that we're not worried about throwing anything away. We're more worried about what is the structure that we can get Puccini to work, or get some other more complex musical structures.
One thing that when I was reading the paper that caught my eye was there was a mention of kind of this rhythm and this kind of rhythm model or melody model or kind of rhythm and model split. Yep. Can you talk a little bit about that?
Well, the first thing we do is we create a model for the rhythm, just for the rhythm, without the actual sound, without the scale degrees. And then once that's constructed, then when we're trying to predict what note actually happens, if it's scale degree 1, 2, 3, etc., then we give it the rhythm that was selected, and together with the lyrics that we're composing for and the rhythm, that's how it comes up to the scale degrees that go on top. And doing it separately essentially reduces the search space. It makes it a little bit easier for the program to
we would have had to multiply the search spaces together, right? So the outcome variables of quarter, whole notes, 8 notes, 16, we would have multiplied that number by the number of melody output, and then that would have just compounded the amount of training examples that we needed in order to get what we wanted to get. And sort of that idea is behind it was, there's another paper that sort of went through and manually tried to guess what features were important and did a manual linear function of certain features with a rhythm model, and they did some analysis on that, and we used some of those features in our system, and we thought, okay, well, let's see how well we can predict rhythm. That was like an initial step. And then once you have the rhythm model actually does really well, and we thought, okay, well, that's just giving us more information into our melody model. Now, obviously, it's still introducing some noise into the melody model because of that, but it was worth it in the end the way it worked out, as opposed to having to spend another 6 months or so gathering more training examples in order to have a set size large enough for 100 outcome variables instead of just 16 or whatever it is now.
And another thing that we learned once composers started using our system is that sometimes they want to pick a melody and try different rhythms on it. So that kind of further validates that perhaps learning them separately makes sense anyways, because once they like a melody, they might want to hear it with 5 different rhythm variations.
Right. Yeah, the idea of how a human creator would use kind of the interface, which I think leads me into my next question, and I think we've touched on this a little bit, but what are some of the potential applications of kind of what you've worked on, and how do you kind of see this growing?
Well, so originally the way that I imagined it being used is for a lot of amateur composers, particularly in the electronic music scene, where you see a lot of musicians take existing melodies and produce them in interesting ways, add new interesting instrumentation. And remixing, exactly. But my sense was, as a musician myself, that some of them would perhaps like to create original music. It's a little bit, the rights on performing your own music are a lot better. And perhaps some of them are not doing it, not because they don't want to, but because it's just, yet another thing to master. It's hard to learn. And so that was kind of my original vision. And I kind of stepped away from this for a long time because I started working with classical musicians, where I found out that there are actually classical musicians as well, professional musicians, who are a lot more interested in the harmony and in kind of combining sounds as well, and who are also not very interested in creating melodies, and that's not their expertise. So I'm working with a professor at Long Beach who is who's been playing with ALYSIA, and he really likes it, that it lets him focus on the parts of composition that he really enjoys. Because it gives him all these melody options, and he doesn't have to spend a lot of time on that part. So that was this really big revelation for me, really, really exciting. But actually, even more recently, we started working with some modern composers who compose, describe it. They're not exactly pop, but something a little bit closer to modern music. And I was kind of, my original ideas were reaffirmed that modern composers who compose for kind of a younger audience also like not having to spend as much time on creating melodies, and that it's very challenging for a lot of them, and that it's nice for them to have a tool that just does it for them. All they have to do is choose.
Yeah. I think it's just meant to be an easier way to explore the space of possibilities, right? Because ultimately, when you're a musician, you're creating something, you sit down at a piano and you just explore. And I think having something explore for you is not necessarily a bad thing if you want to save some time, or you're interested in, like you said, other aspects of the composition, like the lyrics or like the harmonies or the rhythm. Maybe you have different things, and I think creating an interface, getting right now the interface is definitely something that needs a lot of work to allow people to do all these various things that they might want to do, like keep the rhythm and change the melody, or maybe keep the melody and change the rhythm, and all these different aspects of it that are kind of planned for.
Yeah, because right now we're doing it from a research perspective. The system is very easy to use, but there's a gap between easy to use from a research angle and easy to use for a broad audience.
Right, like the actual commercial application of the Adobe Photoshop of this, yeah.
Whatever that's in here, designing some sort of fancy interface with,
Which would be so fun.
Yeah.
Yes.
It's not exactly my area of expertise.
No. You're not an expert in everything.
No.
Let me take a moment to say that this wouldn't be possible without companies like Amazon.com. If you have experience with machine learning and are looking for a new challenge, they have over 100 opportunities available. Be sure to check out the link in the description, and let's get back to the show. Cool. And so you mentioned that you guys have a lot of different ideas with this, which I think is really exciting. Some of the people that I have on, you talk about the research application and the commercial application. I think kind of reading any of these papers, some of them are really tidied up in a little package and saying like, hey, I wanted to test this hypothesis, and I was able to do that, and that story's over. And I think your guys' story is not quite that. And so, what are you able to share in terms of your plans or maybe milestones of kind of what we could expect next?
Sure, I'd be happy to tell you. So the next exciting, so currently several composers are using it. I'm really excited to hear the compositions. We already have some compositions done. And kind of an interesting next step is in April, there's going to be a performance of these songs that were made with ALYSIA.
That's awesome.
Yeah, part of the Pacific Project at San Jose State University, and I'll be performing it, so it's kind of exciting, bridge those worlds. And then more long-term, also still on the art side, we're working with James Morgan, also from San Jose State University, to put on an opera that relies on this songwriting system for coming up with a melody. That's just beyond exciting. And on the technical side, we have a lot of stuff going on. We have a project actually on lyrics generation. We're looking at adding chords. We're looking at having the system combine melodies so it can become more autonomous. It has a lot of arms.
Yeah, there's a lot of features that we're still exploring, a lot of different models in terms of the implementation side that we're exploring, and then we need a UI that's going to make it easier for us to make quick changes to these various things. When people, there's a lot of people that are using it now. We didn't anticipate all these people like wanting to use it so fast. So it kind of caught us off guard. We don't have like a really easy way for them to do it, and we'd like to make it obviously easier for them. We were using a statistics package R to do some things that it's not exactly the fastest tool in the world. And so, bringing that out of R into something like Python and various things that we have to do to make this a usable thing that we can package up and have people.
Well, widely usable.
Widely usable. Yeah, like something that people can sit there and have like, a program that they can just run and have it do it rather than having to do some steps themselves.
Yeah, that the R thing is really interesting. I was a co-founder of this fantasy football analytics site, and we had done a lot of really awesome statistical analysis with R. And people started wanting more and more access to the data, and we wanted more and more dynamic things. And so we kind of, I think there's a thing called Shiny R or something like that, which is this kind of pseudo web interface commercial application of kind of exposing certain elements of your R code in an easy way. And it was amazing how poorly that scaled on the web. And so I remember that grind very much of switching everything over to Python and trying to get it to work a little bit more friendly with an actual kind of different interface that enabled more of a commercial application. So I remember that grind.
Yeah, exactly.
So, well, good luck with that. It sounds really interesting. I would love for you, if I don't know if you have a URL or anything that'll link. There's more information on the event that you talked about, or whether you can send me a note after the show. I'd love to share it around when it happens, or if people want to sign up for more information.
Oh, that sounds great. Yeah, absolutely. I'll send it to you.
Cool. Well, thank you very much for taking us through everything and being on the show. Really appreciate it.
Yeah, thanks for having us.
Yeah, thank you.
Cool. Thanks.
Thanks.